Okay, here we're going to go over, we're on page 15 and we're looking at example 4. And the problem that we're given is that we have sodium nitrate and sodium NH2 becoming sodium azide, which is NaN3, plus sodium hydroxide and ammonia. And the equation is balanced. And what we're told is we have 15 grams of sodium nitrate and 15 grams of sodium NaNH2. And we want to know how much of the sodium azide, NaN3, is produced, what is the limiting reactant, and how much of what we have left over. Okay, so if you remember, when we were looking at, let me back that up a little bit. It was a little too fast. That if we start with the grams of something, and we want to do some stoichiometry, we have to convert that first to the moles of the given substance that we're working with. And we can convert that using the mole ratio from the balanced equation to the moles of the substance that we want. And once we have it in the moles of the substance that we want, we most likely want to convert it to something like grams of the substance that we want. So that's what we're going to do. We're going to take both reactants and we're going to figure out let's go back. We're going to figure out how many of each substance will produce the amount of sodium azide, and we're going to compare, just like we did with the sundaes, which one will make the least amount of stuff. That's our limiting reactant. Okay, so let's take a look. So I'm going to first convert sodium nitrate to moles of sodium nitrate. I'm going to use the balance equation to go from moles of sodium nitrate to moles of sodium azide. Once I have moles of sodium azide, I can convert that to grams of sodium azide using the molar mass. And when I do all that, and I make sure I can cancel all the units, I end up with 11.48 grams of sodium azide. Now I take the next reactant, which is 15 grams of NaNH2, and I'm going to convert that to moles using the molar mass. And once I know the moles of that, I can convert to that number of moles, 3 from the balance equation, to the moles of 1 mole of sodium azide. And then I convert the moles of sodium azide to grams of sodium azide, again using the molar mass. And this time I get 8.33 grams of sodium azide. And what that tells me is the limiting reactant is NaNH2, because I can make the least amount of sodium azide with it. I only get 8.33 grams from that, where I get 11.48 grams from the sodium nitrate. So sodium NaNH2 is what's limiting, just like the chocolate syrup was limiting in the sundaes. So the next question is how much is excess, and that should have 2 S's on the word excess. So in order to figure out what's excess, I've got to take how much sodium azide I can make, and I am going to figure out, based on making that amount, how much of sodium nitrate it's going to take. And once I know how much it's going to take, I can subtract that from the amount I started with to figure out how much I have left over. So let's do that. So I start with the 8.33 grams of sodium azide. I'm going to convert that to moles of sodium azide. And once I have moles of sodium azide, I can use the balance equation to convert to sodium nitrate and convert from moles of sodium nitrate to grams of sodium nitrate, which tells me I'm going to need 10.9 grams of sodium nitrate to make that 8.33 grams of sodium azide. So that's how much I use. I started with 15 grams, so in order to figure out how much I have left over, I've got to subtract, right? So that's how much I use. I'm going to take the 15 grams I started with, subtract the 10.9 grams I used, and I'm going to end up with 4.1 grams of sodium nitrate left over. And that's going to do it.